Welcome. On this channel, we share the freshest insights from the world of neural networks, hardware, and technology. Subscribe right now so you don't miss a thing, and if you need your own AI agent, reach out, and I'll help you build one tailored to your needs. Today, we're exploring a modern fairy tale. We'll discover the cyber fable of KV flash technology. It's a beautiful story of heavy digital burdens and incredibly wise solutions. Let's look back in time to understand a very modern problem. We're exploring the realm of artificial intelligence. It's a magical tale about memory and machines. Long ago, ancient Slavs wrote in fragments. They used heavy, awkward strokes carved deep into wood. Well, today, neural network memory works much the same way. The context cache grows heavier with each new word processed. This forces the language model to read this enormous volume over and over again. It's a heavy burden for any local system. It's literally like asking our machines to carry massive loads, just like the ancient elders carrying heavy bundles of wood. Part 1. The Home Server Outpost. Inside our modern fortress sits a highly powerful NVIDIA RTX 6000 video card. It conceals 48 gigabytes of VRAM. A faithful furry spirit guards his hardware, where we conduct severe tests. We're using the brand new Luz KV flash technology. This technology is beautifully designed to elegantly compress gigantic context. It makes mighty hardware accessible for everyday home users just like us. Part 2. The Heavy Giant. We decided to test the absolute limits of our server. We downloaded the legendary novel War and Peace. This immense text equals 128,000 heavy tokens. We asked the powerful Quen model to describe the main characters. We placed a massive weight upon the shoulders of our digital hero.
Under this pressure, the neural network became like the hulking giant Siatagore. It was struggling to read an endless scroll. First read times dragged to 6 long minutes. Text generation slowed to a painful crawl of just 9 tokens per second. The whole process consumed 21 gigabytes of VRAM memory. And of that massive amount, 6 gigabytes were used for the cache alone. The digital giant was truly exhausted, buckling under the immense weight of the story.
We clearly needed a magical solution to save our outpost. This is exactly where context cache compression comes in. This magical technology uses Luz KV flash to compress gigantic context. It helps small graphics processing units by intelligently offloading memory. It acts as a brilliant bridge between a heavy burden and a swift resolution. The absolutely crucial point here is that we don't need infinite memory. We just need to manage it with great wisdom. Part 3. The Wise Goddess. Acting just like the wise goddess Moash, KV Flash smoothly sorts through glowing threads of data. It separates the essential from the superfluous. It keeps exactly 16,000 important tokens on the video card, then it sends the remaining data away to standard RAM memory. Then, like the speedy winged messenger Samaralle, the system retrieves the required information instantly upon request. Order is beautifully restored to our realm. Part 3. The Magic Results. The results were absolutely fantastic. Generation speed surged from 9 up to 22 tokens per second. The first read time dropped to just 4 minutes. VRAM consumption fell beautifully from 21 gigabytes down to 17 gigabytes. A nimble young warrior confidently evaded the heavy giant. The magic completely saved our precious computing resources. Now, you might wonder if we lost any detail in this magical process. Absolutely not. The neural network maintained perfect quality. It accurately recalled every character and important topic. This proves that long context no longer kills your hardware. The optimization spell worked flawlessly and kept every single detail perfectly intact. Part 5. A Bright, Independent Future. We've proven that artificial intelligence is truly accessible to everyone. We don't need to depend on the greedy Koshi anymore. Massive cloud corporations are losing their former monopoly power. Local sovereign neural networks can now run directly on our own hardware. A bright and independent future has already arrived, and it's running right now on our sovereign server. Thank you for joining us on this explainer. Many more magical discoveries await us. Local sovereign neural networks can run directly on your hardware today. So the only question left is, are you ready to build your own digital outpost?